Hey everybody, today we're trying to show that for any positive integer a, we can find specific, we'll call them x sub 1, I guess, y sub 1, which are both of them are integers, not necessarily positive integers, such that x sub 1 quantity squared minus y sub 1 quantity squared is equal to a cubed. So that's what we mean by a solution. It's just an ordered pair solution. Okay, equals to a cubed. Now, y'all, a is, again, considered to be a positive integer. This n stands for natural numbers, which is just synonymous with positive integers. Yeah, just a quick note, if a were 0, the answer is trivial, right? You just pick x and y to equal to the same integer, and you have as many solutions as you want. So we're interested in so-called non-trivial solutions here, I guess. All right, so let's move along. I've done most of the work, so I don't really, there's not much to say. I'll just go over it here real quick. We do some very natural stuff here algebraically, do the difference of two squares. Then we factor a cubed into a to the first power, put it there for emphasis, okay, times a squared. Now, basically the whole problem boils down to the fact that the y's eliminate. If you add x plus y equals a, in other words, we're equating this factor with the factor a, okay? And then we're equating x minus y with a squared. If you add those two things together, the y's self-eliminate, okay? And so we get this result here. So we've already figured out an x value as a function of the constant a. Now, we do have to note that a plus a squared is an integer, which is really what the problem's asking. You know, we're looking for integer solutions, right? Looking for integer solutions here. Now, of course, if a is even, you're going to have an even number plus an even number, which is even, and so that's going to resolve to an integer. Now, if a is odd, a squared is also odd. That's an inevitability. It's easy to establish. So the sum of two odd numbers is even. Okay, so really it's just a very basic parity argument here. You just consider a odd, a even, and it falls out very quickly. Okay, so we have one solution. Now we can find y, since we know that from right here, from this statement right here, we know that y is equal to a minus x. Well, we figured out what x is right here, and after you do the algebra, you get an a minus a squared over 2. So you see, it's kind of just like this problem is symmetric looking, sort of the answers are symmetric looking. So we finished the problem. These are the values of x and the value of y. In other words, as far as the way we've done this, this would be like the x sub 1 I was talking about right up here, okay? And this would be the y sub 1 if you need to see just the notationally now. Now I have a concrete example, okay? I have a concrete example of this. I picked 12 arbitrarily, and then I'm just using the results we established right here, folks. I'm using these two results, x sub 1 is equal to this, y sub 1 is equal to this, doing all the arithmetic for you, and you get 78. Now also, because it's y is squared, 66 would also work. So I could technically put plus or minus right here for the y. All right, but it's not important. We're just supposed to find solutions. But anyway, 66 would also be a solution, okay? All right, now let's check it, okay? And y'all, this is cool. I like this a lot because nowhere in sight do you really need a calculator so much. Notice that 78 is 6 times 13. Okay, that's what 78 is equal to. And then 66 is 6 times 11, right? So the prime factorization cuts down on the amount of, so when you pull that out in squares, you get 36, but you still have 13 squared minus 11 squared. Now at that point, one might argue, well, you need a calculator, but that's an easy calculation. Also, that's 48, okay? Now, how in the world is this equal to 12 cubed? Well, notice that this is, this right here is 3 times 12, right? 3 times 12 right here, and this is 4 times 12. So we have 3 times 12. All right. And then 4 times 12. Well, golly gee. That's certainly equal to 12 cubed, right? 12 times 12 is 12 cubed, and then 3 times 4 is 12. 12 times 12 is 12 squared, and 3 times 4 is 12, so you get this. So you see, it's kind of neat. We did this pretty much in exponential form. A little bit of arithmetic had to occur right here at 13 squared minus 11 squared, okay? But anyway, that proves it, folks. And again, this really, this part right here proves what we set out to prove. We found solution in terms of the constant on the right-hand side, x sub 1, y sub 1. All right, thank you for viewing.